Welcome back, Honors. All right, so, welcome back to the weekend. Of course, after a big test week for y'all, which a lot of y'all did very, very well on, and I was very, very impressed. Needless to say, y'all kind of figured out that that was a very, very simple unit that was just more thematic, less kind of this person did this person did this story in order. A lot of y'all felt like kind of deceived by how simple it was, and it's really, really okay, and some of y'all did really well. But now we're getting back into a unit that y'all are going to really enjoy. A lot of you will really enjoy it, I think, just because of its intrigue, its interest, its multiple characters involving themselves with one another, and they play off each other, and kind of the building forward and progression of ideas, okay? So what we're going to do, though, today is we're going to start the first half of the unit. So go ahead and make a brand new page notes, all right? And you're going to be Unit 7, all right? Unit 7, and the title of this unit is The Scientific Revolution and the Era of Absolutism, all right? So we're now getting into this era of absolutism and the scientific revolution. Now, these are two things that kind of coincide with one another, but then at the same time, they kind of don't. All right, so they are two things that are running parallel next to each other, and by the end of the scientific revolution, absolutists become heavily involved with the scientific revolution. They kind of, so basically what I'm saying is like one does not necessarily indicate the other, all right? So, but we're starting off with the scientific revolution, and the biggest thing about the scientific revolution is how it's going to change the views of not just the universe, but everything in totality. Like, I love the scientific revolution. I think it's amazing. I love science in general. If I could teach any other thing that's not history, I would teach science in a heartbeat. I find particularly astrophysics to be absolutely mind-bogglingly fascinating. So where we're going to start is we're going to start how, like, nowadays we understand that the movement of bodies through space, right? We understand what it is that exists outside of this planet. We understand how we move around the sun. We understand the sun's interaction with us. We understand magnetic fields and everything else. But that had to start somewhere, right? You had to have a base to work with. And so this is a title in your notes, is going to kind of be where we started with all that. Because at the very earliest onset, you had philosophers like Aristotle and Ptolemy, and they believed in what most people refer to as a geocentric model to the universe, right? They believed that the Earth was stationary and the things in the skies and in the heavens were moving around us, okay? Now, Aristotle is going to theorize the idea that Mercury, Mars, Venus, some of the observable planets that he could see were definitely planets and not stars, and he starts to figure that out by charting their movement through the sky. But the big thing, though, is like he thought to himself, I cannot feel the Earth beneath me moving, so the only rational understanding of the movement of the bodies outside of Earth that I can come to is the fact that they are moving and I am not, okay? So we don't blame Aristotle for thinking these things. No one goes up to Aristotle and is like, hey, good job, dummy. Like, if I end up in limbo after I die, I'm not going to go up to Aristotle and be like, you thought you were smart. It's just that he didn't have the tools or the instructions or the things around to actually continue to understand the movement of the planes of the Earth. Now, Ptolemy comes along, and he starts to theorize the idea that maybe we sit inside a multitude of spheres. Like, he actually believed that there was a giant sphere of stars, right? And that light existed out of it. And there was almost like holes on the outside of that, like, sphere of stars, and light shone through them, right? So he didn't necessarily understand what a star was. But he also, Ptolemy, on top of this whole thing, is going to be the first person to actually theorize and prove the fact that the Earth is round, because he actually is just going to go up to a high point, and the horizon is going to curve a little bit, right? And he's like, oh, well, we must have a curvature that continues, so we must be round. These must be spheres. All those other spheres, though, including Mercury and Venus and Neptune and all these other, like, nifty little, like, God-named planets, are all hooking their way around us, though, right? So we don't blame these guys for thinking that. But this is what they believed in. They believed in that there was an infinite set of stars, possibly holes, according to Ptolemy, in a big, big, big black sphere, and that, like, other bodies were moving their ways around us, right? Now, the moving forward thing, though, just so you understand, I'm going to go ahead and throw this up here. Geocentric, what it means, if you want to be able to have a definition to write down and understand so you know going forward, I'm like, okay, I got this. Geocentric means Earth Geocentered universe, when the sun revolves around the earth, that the earth is stationary and not moving, right? So that is the actual idea that this whole scientific revolution is going to begin itself upon. Now remember, Aristotle and Ptolemy are ancient Greek philosophers. Ptolemy is technically a Hellenistic Greek philosopher going into the Roman era, but we're not going to like cut hair, like we're not going to like split hairs about this, right? So the big thing though is that they are ancient philosophers that became before the Middle Ages. Now going into the Middle Ages though, what becomes the place, so from 500 AD, from the fall of Rome, to about 1500 AD to the height of the Renaissance, who was the biggest and most like large-based intellectual scholarly venue that you could go to find out information? It was the church, right? The church was the one that was the birthplace of universities. They were the place where people still knew how to read and analyze and understand data and things like that. Well, the church being the intellectual center of the Middle Ages, they believed to also propagate that idea of the geocentric universe, okay? So the church is going to continue to believe this. They're going to believe that angels maybe possibly push the bodies around the earth. Maybe these different things happen. Now, coming off of this right here, this is actually an illustration from a Middle Ages book that actually shows angels right here on the outside moving the planets around the earth. Now, again, a lot of people kind of don't get threatened by this whenever I teach it, but some people are like, well, is this Mr. Terry attacking the Catholic Church? No, it's actually not, all right? So I'm not attacking the Catholic Church. I'm not saying that they're foolish for thinking these things, because if you actually look at a lot of scientific advancement, the Catholic Church has been on the forefront of some of it. The Big Bang Theory was actually first theorized by a Catholic priest, right? So the big thing that I'm getting at is just that during the Middle Ages, these scientists and these priests were much more focused on faith. We're much more focused on the involvement of God in the faith and also God in the universe, rather than understanding the movement of the use of gravity, the movement of bodies, the idea that we are so small on top of such a huge surface that's why we can't feel it moving. So they're just going to continue to push forward the ideas of Aristotle, Ptolemy, and the people that came before them, right? But then this guy comes along, okay? This dude's name is Nicholas Copernicus, right? Nicholas Copernicus is going to be alive during the 1500s, early 1500s, and the big thing that he's going to do is going to be the very, very first person to theorize the concept of heliocentrism, right? So he comes along using mathematic models, and he's trying to use the progression and understanding of the bodies in motion in the universe from his observations, from his scientific station in Poland, by the way, is where he's from. He's a Polish scientist. And he issues his ideas of a heliocentric universe, right? And this is what he looks like, and he looks exactly like Lord Farquaad from Shrek, and it creeps me out every single time I see him. Look at him. Identical. It's creepy, right? So, but the big thing that he does is he then writes all of his ideas down, right? Using mathematics and several hundred pages to explain this in a book that he writes and issues. And you can actually see the model that he proposes right here, that the sun is here and that all the bodies move around it. And he actually accurately placed us with Mercury, Venus, us, Mars, and then actually the proper progression of the planets that he could observe. He actually couldn't see Uranus. Sorry, and he couldn't see that planet, and he also couldn't see Neptune or Pluto or some of the other ones on the outside in that outer rim due to his lack of technology. But he did use mathematics and also just the understanding and charting of the universe to understand that we are actually in this right here, heliocentric model of the universe, that the sun is in the middle, okay? And his book actually is very, very famous, and a lot of people in colleges and a lot of college professors refer to it as De Rev. Jot that down, okay? De Rev. D-E space R-E-V, right? That is the shortened name for the book known as De Revolutionibus Orbinibus Coelestium, blah, 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 which in Latin basically means on the movement of the heavenly spheres, right? So talking about the spheres that move around us and the actual fact that we as a sphere move around the sun, okay? Now, his theory is going to be rejected heavily. By the way, shoot a year into that as well. That's 1543 that his book is published. Fun fact, he actually dies a few days after it actually comes out. Some people believe that he was waiting until he knew he was going to die. He wanted to publish it on his deathbed, is what some historians claim. Some historians claim that it's just it just takes a long time to publish a book, and maybe he just died, right? So, we're not really sure. But he did avoid a lot of persecution from the church and or any other major what's the word I'm looking for? Clerical or lawmaking body. He actually is not going to be tortured, arrested, or any of this other stuff. when he proposes this concept of heliocentrism, right? And so everyone is going to begin to refer to heliocentrism as the Copernican system, right? So they're going to say that the Earth actually goes around the sun, but the problem is a lot of experts, quote unquote, are going to reject his theory. Now, my wife is somewhere nearby, and I'm trying to make sure I'm being nice about this because this is something that she gets mad at me for talking about sometimes, but most experts are going to reject his theory. And the reason why is because of this, retrograde motion, all right? So now, retrograde motion is a very strange thing, all right? It is an observational phenomenon, but the Catholic Church and also the scientists within the church that were sponsored by the church disapproved of Copernican systems and heliocentrism because of retrograde. Look, it's just not real.
Have you ever been a student in an all-girls school during Mercury retrograde? I don't think so.
I love you.
Love you too. It feels real, doesn't it?
All right, anyway.
Feels real.
The retrograde motion idea, it's an illusion, all right? So because of where we are, I'm not getting into that yet. All right, hold on. So let's discuss the retrograde theory, okay? So the big thing about it is the Catholic Church and the scientists that were sponsored by it at the time, due to no fault of their own, but literally just using their powers of observation, believed that there was no way that we went around another body because it appears for several months of the year as if some planets are moving backwards, right? And so the big thing about it, some people say to themselves, well, we can't possibly be going around the sun if other bodies are moving in erratic patterns, because if they were, we would be able to observe them continually moving in a straight line, right? So this right here, that's retrograde motion, right? It happens to apparently Mercury for about a month out of the, or 1 month, for about a month in time, and happens a couple times a year. Now, this is the observation of Mars retrograde, right? Which also apparently retrogrades as well. But look right here. See where we on the Earth, it actually isn't moving backwards. It has to do with the sun being positioned where it is, and the fact that the light is being cast past us, past the planets beyond our orbit, and then into the stars as it basically almost like a projected illusion, right? So the way it appears is that it's actually moving backwards. But it's not. And the problem was that Copernicus had no explanation for this, right? And also, big thing to understand too is that it's okay that we found out that retrograde motion is not actually a real thing, and it's not actually doing anything differently than it ever does it. It's actually just kind of a phenomenon. Because we used to think Pluto's a planet, but we don't even believe that anymore. Some people, scientists still argue this, but look at poor Pluto. He got kicked out of the Universe Club. I feel bad for the guy. He's actually just a big ball of ice and dirt. Now, anyway, so big thing though, Tycho Brahe is then going to come along, right? And he is a Danish scientist that looks deceptively like a walrus, and he tries to tackle this whole retrograde issue, right? Now, Tycho Brahe has a funny little story to him. He is a Danish scientist. He is wildly wealthy, right? Very, 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 very rich. And he is being recruited by other European kings and also other European governments to come to their area and become basically a Renaissance scientist, right? We will pay you money, Tycho Brahe, to come over here and be smart, right? Come be smart for us. But the Danish king, where he is from, tells him, I'll do anything to keep you. Please just don't go anywhere. And he says, well, I want an entire laboratory. I want an area to do all my work in. And the Danish king goes, okay, fine. And he gives him an island, right? He gives him an island, and on that island, he has 2 huge buildings built, right? One is for the stars, the other one is for general sciences, right? And in the stars one, he has the most modern telescope that it's not that good, but it's a decent telescope that exists, and he is observing the movement and the patterns of the stars. And he's doing all this without the tip of his nose, all right? So, this is actually his prosthetic right here, okay? He was missing the tip of his nose because he is a very, very cheeky kind of character, and he got into an argument with his cousin one time over a math problem, and they pulled swords on each other and had a duel, and his cousin cut the tip of his nose off on accident. And so he used to have to wear a wax prosthetic around everywhere and actually keep it on his face. But if he ever actually drank too much at a party, or if he ever got too angry and he sweat, it would fall off, which I find absolutely hilarious. Now, anyway, but Tycho Brahe, this Danish scientist, is going to spend years trying to see who's right. Is it Copernicus? Is it the church? Who is it? He actually comes up with his own system, which is not that good, and it's called the Tychonic system, where the sun is still, or the Earth is stationary, the sun goes around us, but then all the planets go around the sun. So it didn't make any sense, right? But the big contribution of Tycho Brahe is not his idea of the universe. It's not him trying to solve retrograde motion. It's not him trying to figure all this stuff out. His biggest contribution is his data, all right? Scientists and everything they do hinges upon data, right? It hinges upon the idea of, I need numbers, I need facts, I need formulas, I need everything, right? And so he begins to record everything he observes down in these things known as the Rudolphine tables, right? And in the Rudolphine tables, he records the movement, structure, pattern of motion, and like the different yearly inflection point of all these different heavenly bodies. So many of them, in fact, that it's 777 different ones, right? So in this book, the Rudolphine tables, 777 different stars, different planets, and their movements are identified. So he provides just a massive amount of data to use, okay? He also observes a supernova. He's the very, very first person to observe a supernova actually occur through his telescope, right? And he sees a star explode. Now, remember, going back to Aristotle and Ptolemy, everybody believed that the heavens started right outside of Earth and that we were looking into heaven at night, right? Like that everything out there was perfect because we were garbage and the universe is terrible, according to Aristotle. But he basically saw a star die. And he was like, wait a minute, if I'm seeing a star die and things explode, there's nothing perfect out there. It's like a whole other realm, right? So the Rudolphine tables is a huge contribution. But then his assistant, all right, comes along named Johannes Kepler, who is a German scientist, and takes all of his information and all of his numbers, and he applies it to mathematics. And he takes the Copernican system, and he uses all that data to try and mathematically prove heliocentrism, right? And the big way he does this is he fixes the retrograde motion problem. He solves it. He is like literally steps back and he's like, I figured out why we think planets are moving backwards when they're not, all right? So, and he actually says the orbits, they're not perfect circles. They're actually ovals, right? We are moving at different speeds. That's why it appears that it's moving backwards. Because during certain times of the year when the Earth is here and the Mercury is beginning to go around the sun early, it looks like it's going backwards, but it actually isn't, right? It has to do with the pattern of the orbits. So that's a massive, massive thing. And that happens in 1609, right? And we got one more thing to talk about, and then we're done. And then y'all have like moved so officially through this flip, and it's awesome, okay? So Johannes Kepler comes along with Brahe's numbers, using Copernicus's idea, and he actually creates these oval-shaped orbits, right? And actually, the big problem, though, that we still have is there's no proof, right? So that's the issue with science, right? You got to prove things, right? You have to have concrete, physical, and mathematical proof. Now, we have the mathematical proof, right? Johannes Kepler provides the math, and he provides the ideas using Brahe's numbers to prove heliocentrism, right? But no one has strict, no questions, no doubt proof until this guy comes along. And some of y'all have heard of his name because of a Queen song, and I butchered the spelling of it right here. His last name is actually Galileo, and it's spelled like G-A-L. Hold on, let me look it up.
Like his first name, but with an I.
I know.
Galilee.
Okay, maybe the retrograde motion's not real, but my wife can spell a lot better than I can. How's that sound? So she is right. His Galileo Galilei is actually spelled G-A-L-I-L-E-O is his first name, and then it's G-A-L-I-L-E-I, right? So it's just literally the same name twice, but instead of an O, it's an I at the end, okay? Oh, nice, sweetheart.
It's like I was an English teacher.
Like, so anyway, now, I guess teaching English doesn't teach you about how planets move. Now, anyway, so here we go. But the big thing about it is...
Am I supposed to be offended? Like, they just were like, Pluto isn't real like 4 years ago.
I love you.
I love you too, but give a sister a break.
So, Galileo Galilei, for those of you who have heard of him before, is an Italian scientist, right? And he is going to come along and he's going to prove heliocentric design, okay? And he's going to use the development of his brand new, big, fancy telescope that he creates, okay? Now, did he create the first telescope? No. He just took a design and improved upon it, right? The very first one was actually invented by a Dutch guy named Anton something. Now, what the simple telescope was, though, was just two lenses that looked through and it bounced light off once, twice, and then came to your eye, so it was slightly magnified. What Galileo does is he begins to develop telescopes that have multiple refracting lenses inside of it, so it bounces the light off multiple times, and when it comes to your eye, you're actually viewing a 30 times magnified image, which is a pretty intense design for the early 1600s, right? And the interesting thing about Galileo, too, is he was like a professional smart guy, all right? So, like, what ends up happening is Galileo is kind of the Renaissance model of a scientist. He is basically a Renaissance figure in and of himself. People paid him to be intelligent. And what he used to make for people all the time as proof of his intelligence and proof of their investment is he would give them telescopes all the time. And a lot of times telescopes were not actually developed to look at the stars. Telescopes were originally developed to look at ships out in the harbor so they could spot them before they got there. But Galileo begins to use his at night to analyze comets, the moons of Jupiter, and other moving bodies in the universe, and he realizes a relationship between heavenly body and their size using mathematics to prove the heliocentric model. Because what he does is he realizes, one, when he looks at the moon, he's like, wait, the moon is not a perfect body that is just smooth on all of its sides. It's covered in little pock marks and boulders and craters and all the, not boulders, but like craters and all these other things from it being hit by so many moving bodies. So that means that it has a certain force about it that's pulling these bodies into it. And then he observes the moons of Jupiter, which he actually names most of them, including Titan, after like several other Greek figures. And he actually sees, wait a minute, Jupiter is very large, and its moons are going around it. And since its moons are smaller than it, that means that larger things are more stationary, smaller things go around them, and he basically figures out using a force that he doesn't even know what it is. He doesn't even know what gravity is, but he's like playing around with the idea, right? So he relates the size of a body to its being able to pull things into orbit, and he is 1,000% confident that the sun is larger than the Earth. So we must be going around it, okay? So he then begins to go out there and issue a lot of his ideas, right? And this is one of his earliest ones. It's a pamphlet called The Assayer, and it actually is talking about the movement of a comet. Now, interesting little factoid that's very, very important. This is one of his best friends. That right there is Pope Urban VIII, right? So him and Pope Urban were actually very close, talked regularly, believed in each other's ideas. And what happens is Galileo goes up to his boy Urban after dedicating this pamphlet to him. You can actually see on the dedication, it literally says it's being dedicated to Urban VIII on it, right? So the big thing about it, though, he goes up to him, he's like, Urban, I know you like the pamphlet I wrote about the comet and stuff like that, but I got an even better idea. I think I just proven that we go around the sun and that it does not go around us. And Urban looks at him, he's like, big fella, we were pretty aware of that, right? Like, so, like, Urban even looked at him and, like, confessed to him, and he said, in the Catholic Church, we've been pretty confident for a long time that that is actually the case. But the problem is that there are parts of the Bible that say that we are the stationary object and that the sun actually goes around us. So we have to be very, very careful on how we release this information. If we were to just be like, hey guys, just kidding, like it could cause a lot of hysteria, nervousness, non-trustworthiness of the church itself, and also not to mention the fact that the Catholic Church was currently in the midst of a war, known as the 30 Years' War at the time, when he actually wanted to issue this thing. So the problem with all this stuff is Urban is trying to play like a PR game, an actual public relations marketing game. He wants the information out there, but he doesn't want to issue it as if the Catholic Church has been wrong. So he tells Galileo, look, you can write your stuff down, but I need you to also propose the church ideas as well, okay? And so Galileo tells him, okay, I can do that. And so what he does is he writes a book, and Galileo's book is called The Dialogue on the Two Chief World Systems, right? And what is happening in his book is there are three figures, right? There's one right here in the middle, okay, who doesn't know anything about space, and they're at a bar. And two guys are trying to convince him which system is right. Is it geocentric or heliocentric? The guy who is propagating for Galileo's ideas of geocentrism is actually very suave, very intelligent. He's using mathematics. Unfortunately, Galileo makes the church really mad when he makes the church figure a guy named Simplicio, which literally means idiot, right? So, and the problem is that he sounds really stupid, and he's not using any kind of math and all this other stuff. And so the church gets very upset with him. And he is going to be tried in front of an inquisition for heresy, and his buddy Urban goes up to him, and he's like, look, I'm trying to make sure they don't kill you because you did a really, really dumb thing, and you made me look bad, and you made the church look bad, right? So we really need you to back off a little bit. And all these other priests, dude, they want to see you burned at the stake for going against the church. And Galileo was like, well, I can't just not, what do you want me to do? And then what he tells him, he's like, look, recant, take back the things you said, and I've talked to the priests, and they said that they would just put you under house arrest for the rest of your life. And so Galileo takes it, right? He takes this punishment. He says, okay, I didn't mean what I said. And then he ends up under house arrest for the rest of his life, and he dies under house arrest. And it's a really, really funny system, because in the long run, I think that Galileo got the last laugh, right? Because we know that he was right to this day. And also, fun fact, his middle finger is preserved in a jar, which I actually think is really funny, and also just very ironic, right? So, but the reason why his middle finger is in a jar is due to the fact that some Italian guy dug his body up 200 years after he was dead, removed the finger, and then sold it at auction, right? So, and this is actually it in the jar itself. As you can tell, like I said, in the long run, Galileo gets the last laugh, right? So, but that's it. I'll see you guys later. Y'all have a great weekend.